Hello all, welcome to another LeetCode problem. So today we are going to solve problem number 99, recover a binary search tree. So basically you are given a BST, binary search tree, and then from this particular BST there are two nodes which are at the wrong position or they are swapped by mistake. And then we have to identify those two nodes and then recover a tree without changing its structure. So for example, in this example, let's say this is a BST, and then it is given that there are node number 3 and then node number 2 are swapped by the mistake or they are incorrectly placed. So we have to identify these are the two incorrect nodes and then we have to replace their values, and then we have to make in place replacement. We don't need to return anything. So I'll replace 3 with 2 and 2 with 3. So this is my then perfect binary tree. That will be my final result. How do we solve this problem? So there are actually a couple of ways. So first is basically, okay, let's say let's take an example here. So I have taken another example here. So let's say this is my BST. So in this BST, I have starting root node starting with 6, and then you have this 1 4 7 9 11. So we know one of the property of the BST. If I take the in order traversal of the BST, then everything will be in increasing order. So 1 and then 4 is greater than 1, then 5 greater than 4, then 6 greater than 5, 7 greater than 6, likewise, right? So that's the BST. So everything on the left side basically is less than the root node, and everything on the right side is greater than the root node. Right? That's a basic property. So what we have to do is, in case this is the basic property, but what is given is there are two nodes which are incorrectly placed, but in this tree at this moment there is no incorrectly placed. So this is my perfect BST, right? But let's say there is a swap node. Let's say if I swap 4 with 9, right? So let's say I delete this 4 and then I make this as this make this I make this as 9 and make this as 4. So these are not, now this doesn't become my perfect BST because 9 is not less than 6 and then 4 is not greater than 6. So this is not my incorrect BST. So what we have to do is we have to identify these two nodes from the given tree and then replace their values so that this becomes a perfect BST, right? So let's say if I take the in order traversal for this particular tree, so what does it become? So what is in order traversal? So even if we have to take in order traversal, so we take left node first, then we take a root node, and then we take a right node. So let's call it a root node and right node. So that's how travel. So let's say if I start from 6, so I go to left, I see there is a node, and then I go further node, I see this is the leaf node, so there is nothing. So I take 4, and then it becomes 9, then 5, and then it becomes 6, 7, 4, 11. So this is my in order traversal, correct? So let's say I store it in some list or in array or something, correct? Now in I got this array. Now what we have to do is in this array I have to look for those two numbers which are not in increasing order, because that's how BST, right? As I explained, if I take anything BST and then put down the in order traversal, then everything will be in order, increasing order. But in case something is not in increasing order, then those are my the numbers which are not in right place, and we have to replace those. So we'll see how we are going to replace it. First we are going to traverse it. So let's say I start with this first element, normal array traversal, right? So okay, the first element is there. Okay, that's fine. We don't need to look anything. There is nothing previously I have seen. So this is where let's say my root node is pointing currently, correct? Now I move to the next element. So next is what? 9. I'll see whether now root pointer will be at 9. So and make this one point to some, let's say, previous node. So I'll see whether the root node, which is current pointer here, is greater than the previous one. So I see yes, property holds true because 9 is greater than 1, so that's fine. So I don't need to worry about now. So I'll move to the next element. So let's say now I move into this. So this is my current pointer, and then I'll also move my previous pointer. So previous will point to here. Okay. Now I see whether 5 is greater than 9. No, right? Because that's where the property violates. 5 has to be because next element has to be greater than 9. So if this case, once I find this case, then I'll assign previous to, I'll store somewhere else as the first node. This is my first invalid node that I have found. Now again I keep continue. So I look for 6 greater than 5, correct, and then I look for 6 greater than 7, 7 greater than 6, correct. Then I'll compare this one. So once I reached here, right, this is when one current pointer reached here. So I see 4 is greater than 7, and I have already found my first pointer. So in this case, this is going to be my second element, which is at the wrong position, because first element I already found. Second element I'm searching for, because 4 is not greater than 7. So 6 is my second faulty element. So once I go found this first and this second element, I'll just need to replace their values, because I need to make in place replacement, and that's the result. But problem with this approach is this is O of n space. I'm going to use extra lists to store these values and then traverse on the list. But there is a better approach. What you can do is, instead of storing into list, you can directly use this in our traversal of the tree, and then try to figure it out how you can how you can do a in place replacement. So let's say this is my tree, right? Now if I know that in order traversal will help me to identify which are the incorrect node. So let's say I start from this particular node, and I do traversal. I go to the left, and then I go further left. So I came to this particular node, which is a leaf node. So I assign as a previous node. Now if I go to the right, I further travel, because there is nothing to go down here, nothing left, right? There is no child left. So I'll go to the right. So this will become my right node, next node, or previous current node, whatever you call it. I see this right current node 9 is greater than previous node. So that holds your property too. Now again, if I do inward traversal, I came here. So my previous become this, and then this will become my next node or current node. So I see this, okay, this node is basically 5. Whether 5 is greater than 9? No, right? That is where property valid. So I'll assign this 9 to my first node, because this previous is pointing to 9, right? So I'll assign this. I can say, okay, first is my previous node. So now the 9 will point to the first node. So 9 first has a 9th value. Now again I do traversal. I go here. Okay, I go further here, and then I reach here on the left hand side. I see this is where the null node. I mean, there's nothing to traverse here. So now I go back. When I traversing going back in the tree, I'll start comparing. Okay, whether 4 is less than or greater than 7. So I find, okay, 4 is less than 7. I mean, 4 should be greater than 7, but in this case 4 is not greater than 7. So we found another faulty node. So in this case what will happen is, so current node will be root. Our root is basically, I'll be pointing here. So that will I'll assign you my second node. Right, so that's how. Now once I get my first node and second node, I'll just go ahead and replace their values, right? I'll I'll explain this. So that's how the logic works basically. I try to explain the logic here. So either you can take the list approach, where you have this in-ordered list created, but that is simplest way, and that will take extra OF and space. But you can do without list, which is asked in the problem, with O of 1 space, without storing the elements in the list. You just traverse the tree and then try to figure it out what are the two nodes which are faulty, right? So So if you probably for this problem you should know how to do an in-order traversal in tree. If you don't know, then it becomes tricky to understand the traversal piece here. Otherwise it becomes very simple, right? So let's look at the code here. So in this code I have taken three variables that I explained. I need to define what is my first and second node which are faulty, and for the current pointer I'll use it as a previous node, right? And then once I find the both faulty nodes, first and second node, I'm going to replace with their values. So this is a Python way of replacement where you can, without using temp variable, you can replace their values for the node, and that's it. You don't need to return anything because that's what they asked in the question. But you have to do traversal. Now uh, for doing in-order traversal, I'll just go ahead after the root node. So I did left. I go to the left and left because I have to go to first find the left, and then we go to the right, and then we go to the root node, and then we go to the right node. So that's how the root left in-order traversal works. So what is we going to check is we have to find our first node first. Where is my first faulty node? So for what we have to do is, okay, first whether we can check, okay, whether this is equals to none. That means I have never seen my first node. Okay. Second condition, I have to see, okay, the root node where I am currently pointing is greater than, or the root node where I am pointing, whether that number is less than my previous node. So that means when I'm traversing here, right, let's say in this one, right, so this is, let's say this is my root node and this is my uh, previous node. So whether my root node is this less than the previous node, this means this is not in increasing order. Let's say this one, right, this is where my root is pointing and previous is pointing to this root, and the root is what, 4 is less than 7, no, right? So where property goes, so that's when I'll find the faulty node. Same goes here. So let's say when I'm pointing, root node is 5 and then previous is this one. Whether root node is less than 9, no. So this is, so 9 becomes my faulty node. So what I'll do is I'll assign my first node as previous node. Also I need to put it as my previous node should not be none in case. And the second condition is I need to find the second node. So second node, same condition will apply. So only difference is I need to see whether I have found my first node or not. If I found my first node, then only I'll look for second node. If I have not found a first node, then I won't look for the second node. The second node will be basically my root node where I am currently pointing. So if both the condition doesn't satisfy, then I'll just keep traversing and I'll assign my previous to the root node. So these conditions basically will try to uh, basically to help to understand uh, um, whether all the numbers are increasing order or not. Somewhere if I found any numbers which is not in increasing order, basically this combination, right, or this combination, this is not in increasing order, then this will try to capture those conditions, those values for me. And if everything is increasing order, then I'll just keep going ahead and I'll keep track of what is my previous one. So that's the code here, nothing more. Mm, it looks a bit complicated initially, but if you think of as an in-order traversal and then think of whether everything should be in increasing order, then it becomes easy. If I try to run this, so yes, all test cases work. So if you can just submit it. So let's see. Yeah. So 74% not too bad. Uh, I hope you understand this problem. Hope you like the video. Thank you for watching. See you in the next video.